Hello, Hera. Sorry to bother you, but can you help me with understanding a study I recently read in the Journal of Catalogical Sciences?
Always happy to help, Hans. Can you tell me a bit more about the study and the results?
The study showed an important difference between the average meows per day among cats who got treats and cats who didn't get treats. Cats who got treats had higher meows per day. Can you explain to me how the researchers reached such a conclusion? I want to know if I should increase my meows per day so, well, I would get more treats.
As we all know, numerous studies have shown that cats getting treats usually meow on average 25 meows per day, M/D, with a standard deviation, SD, of 5. This is a known distribution. Hans, you may remember that standard deviation is the average difference of a data point from the mean. In this distribution, one standard deviation is 5 meows per day, two standard deviations is 10 meows per day, and so on. Looking at this study, the researchers wanted to know if cats who are not getting treats meowed more than cats who are getting treats. Their null hypothesis was that cats who are not getting treats did not average more meows per day than cats who were getting treats. Hans, if you want to brush up on what is a null hypothesis, take a look at our discussion about the null hypothesis. As researchers try to make a decision, they have to compare what they find with other data. In our case, by comparing the average meows per day in their sample with the average meows per day in a known distribution. In this case, the known distribution is the known number of meows per day by cats who are getting treats. They also know that if they observe a data point, a score or a value, that is less than a predetermined percentage of all of the data points in the known distribution, it is very rare. If they find that the observed data point is less than this predetermined level, it is possible that the observed data belongs to a different distribution. However, they may of course also be wrong. This willingness to accept that they may be wrong and the observed data belongs to another distribution is the alpha level. Hans, if you recall, we spoke about the alpha level in another conversation. If the observed data is less or even more extreme than this predetermined alpha level, for example, 5%, the researchers reject the null hypothesis and declare that they have a significant finding.
Okay, so they want to test the assumption, the null hypothesis, that cats who don't get any treats don't average more meows per day than cats who get treats. But if they could show that there was a difference, they would reject the assumption of no difference, the null hypothesis. They would reject the assumption that there was no difference in meows per day among cats that get treats and cats not getting treats. Also, they compared their results with a known distribution. And finally, they were willing to accept that they may make a wrong decision, in this case 5% of the time, their alpha level, to reject their null hypothesis even though the null hypothesis was actually true. This means that if they found an average meows per day that would be found less than 5% of all average meows per day in the known distribution, they would reject the null hypothesis and conclude that their finding was significant. As we assume the findings has a normal distribution, 5% of all values will be found 1.645 standard deviations beyond the mean. As one standard deviation is 5 meows per day, 1.645 standard deviations above the mean is 5 meows per day times 1.645 equals 8.2 meows per day above the mean. Thus, if they found an average meow per day above 33.2 meows per day, 25 meows per day plus 8.2 meows per day, they would reject the assumption that cats getting no treats didn't average more meows per day than the cats who received treats. Meaning, cats' meows per day who get treats differ significantly from cats who don't get treats. Phew.
Good summary, Hans. Let's see what they found. They went to the animal daycare center and sampled 100 cats who didn't get any treats. The average number of meows per day was 37.5 meows per day. This number is more than the critical value of 33.2 meows per day. It is actually 2.5 standard deviations above the mean. And they concluded that based on this finding, that cats that didn't receive treats meowed more per day, and this finding was statistically significant.
Hera, so if you give me more treats, I will bother you less as my meows per day will decrease.
Good try, Hans, but this is not what they found. They only found that getting versus not getting treats made a difference in meows per day. They did not conclude that there was a correlation between the number of treats and the number of meows per day. Maybe we should talk more about correlations?
Okay, at least give me credit for trying.